Saudi Arabia is building what headlines like to call the world's largest artificial river in the desert, a phrase that sounds deliberately cinematic and a little misleading at the same time. There is no open channel of flowing water cutting through sand dunes, no modern Nile suddenly appearing where camels once walked. What Saudi Arabia is actually planning and already building in stages is a national-scale desalinated water transport network, a dense system of pipelines, pumping stations, and reservoirs designed to move fresh water hundreds and in total thousands of kilometers inland, largely underground, to places where natural water simply does not exist. The reason the word river keeps appearing is simple. It is easier to sell an idea than a utility grid. A river suggests abundance, continuity, and permanence. Pipelines suggest maintenance, energy bills, and engineering headaches. For a country trying to rebrand itself under Saudi Vision 2030, the metaphor matters. The promise is that technology will finally overpower geography, that the desert will no longer dictate what can and cannot grow, and that water scarcity will be treated as an engineering problem rather than a hard limit. The core claim behind the project is scale. According to Saudi planning documents and state-linked reporting, the combined network would stretch the equivalent of around 12,000 kilometers, a figure often compared to the length of the Nile to emphasize just how massive the system is meant to be. The water itself would come primarily from the Red Sea and the Arabian Gulf, produced by desalination plants along the coast, then pushed inland through pipes wide enough to move volumes usually associated with rivers, not municipal plumbing. This is why the project sounds implausible at first glance, and why it attracts so much attention on video platforms that thrive on Megaproject storytelling. Calling it a river also conveniently shifts the conversation away from the harder questions. Rivers do not need electricity. Rivers do not generate toxic byproducts. Rivers do not stop flowing when energy prices spike. A desalination corridor does all of those things. Even its supporters inside Saudi Arabia describe it more accurately as a water corridor or national distribution grid, closer in spirit to a power transmission network than a natural waterway. International business media, such as Bloomberg and Reuters, consistently use language like pipelines, corridors, and infrastructure rather than rivers, and that distinction matters if the goal is analysis rather than spectacle. The underlying motivation is not hard to understand. Saudi Arabia is one of the driest countries on Earth. Rainfall is minimal, rivers are non-existent, and most groundwater reserves are either deep, non-renewable, or already overused. For decades, the country relied on heavy subsidies to keep water cheap, encouraging consumption levels that made sense in wetter climates, but were wildly mismatched to desert reality. By the late 20th century, water demand had exploded, driven by population growth, urban expansion, and an ambitious attempt to turn the kingdom into an agricultural producer. That experiment ended badly, and it quietly shaped today's policy more than most hype-driven videos admit. Saudi Arabia once grew its own wheat by pumping ancient fossil groundwater out of the ground, water that had accumulated thousands of years ago and would not be replenished. The country briefly became a wheat exporter, a political success story on paper, until the water math caught up with it. By the middle of the 2010s, the government acknowledged that the approach was unsustainable and formally exited domestic wheat production. The desert had not been conquered, it had simply been temporarily ignored. This history is crucial for understanding why the new water project is framed so aggressively as a technological breakthrough. It is meant to signal that the old mistake will not be repeated, that Saudi Arabia is no longer burning through irreplaceable groundwater, but instead manufacturing water from the sea. In official narratives, desalination is presented as a clean reset, a way to decouple national development from natural rainfall entirely. The artificial river becomes a symbol of control, a statement that scarcity itself can be engineered away. There is some truth to that claim, but not in the way the metaphor suggests. Desalination works. Saudi Arabia is already the largest producer of desalinated water in the world, operating dozens of large plants and producing tens of millions of cubic meters of fresh water every single day. The new network is not about inventing a new technology. It is about extending the reach of one that already exists. What changes with scale is not feasibility, but cost, risk, and consequence. For an American audience, the easiest comparison is the interstate highway system. On paper, highways simply move cars from one place to another. In reality, they lock in patterns of development, energy use, and long-term maintenance obligations that last for generations. A national water corridor does the same thing, except the commodity being moved is far more sensitive. If a road cracks, traffic slows. If a water pipeline fails in the desert, entire regions can be left without supply. This is why the phrase artificial river deserves skepticism rather than applause. It smooths over complexity and turns infrastructure into mythology. It implies permanence in a system that depends entirely on continuous energy input and meticulous management. It suggests that water will simply flow, when in reality it must be pushed, filtered, monitored, and paid for every hour of every day. Seen through that lens, the Saudi project is not a miracle, and not madness either. It is a calculated gamble. The country is betting that its access to cheap energy, combined with modern desalination technology and massive capital investment, will be enough to overcome the physical limits that stopped earlier attempts at desert agriculture and urban expansion. The river metaphor sells confidence. The pipes tell the real story. As with most megaprojects, the critical question is not whether it can be built, but what it commits the country to long after the headlines fade. Water can be manufactured, but it cannot be wished into existence. Every cubic meter delivered inland will carry the invisible weight of electricity consumed, infrastructure maintained, and environmental trade-offs deferred. The first step in evaluating the project is stripping away the poetry and looking at it for what it is. An industrial-scale water machine, operating in one of the harshest environments on the planet. Asking to be judged not by how bold it sounds, but by how honestly its costs are counted. To understand why Saudi Arabia is willing to gamble on a project of this scale, you have to rewind to a policy decision that once looked bold and later looked reckless. For years, the kingdom treated water as something it could subsidize its way out of, keeping prices artificially low to support rapid growth, social stability, and an ambitious push into desert agriculture. On paper, the strategy worked. Saudi Arabia grew wheat in a place where wheat had no natural right to exist, briefly becoming self-sufficient and even exporting grain. Politically, it was a triumph. Physically, it was a warning sign. The water that made this possible did not come from rain or rivers. It came from fossil groundwater, ancient reserves trapped underground for thousands of years, formed during much wetter climatic periods. Once pumped out, this water does not come back on any human timescale. It is closer to mining than to farming. At first, the scale of the reserves masked the problem. Wells kept producing, fields stayed green, and the illusion of control held. But the math never worked in the long run. By the 1980s and 1990s, water consumption in Saudi Arabia had surged, driven by population growth, generous subsidies, and inefficient irrigation practices that made sense only when water was treated as nearly free. Studies cited by institutions such as the World Bank later showed steep declines in groundwater levels in key agricultural regions. Pumping costs rose, wells had to be drilled deeper, and the environmental bill began to surface quietly but relentlessly. The government eventually acknowledged what engineers and hydrologists had been warning for years. Producing food by draining non-renewable water reserves was not food security, it was resource liquidation. In the middle of the 2010s, Saudi Arabia formally exited domestic wheat production, choosing instead to import grain and invest in farmland abroad. According to data referenced by the Food and Agriculture Organization, the decision was explicitly framed as a water conservation measure, not an agricultural failure. The desert had not betrayed the policy. Physics had. This reversal left a deep imprint on how water policy is discussed inside the kingdom today. Subsidies were reduced, metering expanded, industrial and agricultural users were pushed toward more efficient systems, including drip irrigation and sensor-based monitoring. Water was slowly reframed from a social entitlement into an economic input. That shift alone tells you why the idea of a massive water corridor carries so much political weight. It is not just about supply, It is about avoiding another public retreat. From a German policy perspective, this is the classic story of delayed accounting. The costs were always there, but they were hidden by subsidies and short-term success. Once the bill arrived, the only options left were structural change or retreat. Saudi Arabia chose retreat first, then redesign. The artificial river narrative emerges directly from that sequence. It is an attempt to say, we learned from the groundwater mistake, and this time we are doing it the right way. But even this framing deserves scrutiny. Replacing fossil groundwater with desalinated water does not eliminate scarcity. It changes its form. The constraint shifts from geology to energy and capital. Instead of asking how deep the aquifer is, the question becomes how much electricity the system can reliably consume and at what cost. The risk is no longer running out of water underground, but running into power shortages, price volatility, or infrastructure failures above ground. For an American audience, the analogy is straightforward. Imagine a farming region that once relied on free water from an underground source, then switched entirely to water delivered by an electrically powered pipeline stretching across several states. The farms might survive, but they would now be tied permanently to energy markets and infrastructure maintenance. Every drought would be replaced by a different kind of vulnerability. This is the historical weight behind the Saudi project that flashy videos often ignore. The artificial river is not a first attempt at bending the desert to human will. It is a second attempt, shaped by the scars of the first. That context does not make the project foolish, but it does make it risky in a very specific, very predictable way. The question is no longer whether Saudi Arabia understands water scarcity. It clearly does. The question is whether it is replacing one hard limit with another and calling it progress. When Saudi officials and project advocates describe the artificial river, what they are really describing is an industrial logistics system for water, not something that behaves like a natural river at all. For a US audience used to thinking in terms of pipelines, grids, and utility corridors, the concept is easier to grasp once the language is stripped of drama. This project is best understood as a national desalinated water corridor, a backbone infrastructure designed to move huge volumes of treated seawater from coastal production zones deep into the country's interior. The headline number that keeps circulating is length. Roughly 12,000 kilometers is the figure most often cited, a number deliberately chosen because it sounds astonishing and invites comparison to the world's longest rivers. In reality, this length refers to the combined reach of multiple pipelines, branches, and distribution lines rather than a single continuous conduit. It is closer to the total mileage of an interstate highway system than to one uninterrupted road. That distinction matters because it tells you what kind of engineering challenge this really is. Coordination, redundancy, and maintenance across a vast territory. At the coastal end of the system sit the desalination plants. Saudi Arabia has been expanding these facilities for years, primarily along the Red Sea and the Arabian Gulf. The water produced there is then fed into large-diameter pipelines, some reportedly exceeding 2 meters across, designed to move water at rates more commonly associated with rivers than with municipal supply lines. Supporters point to figures in the range of several million cubic meters per day to illustrate the sheer scale of the flow, emphasizing that this is not about supplying a single city, but about reshaping national water geography. To make that possible, the corridor relies on a network of pumping stations and reservoirs spaced along the route. Unlike a river, water here does not flow downhill on its own. It must be pushed, often against gravity, across long distances and varying elevations. Every kilometer adds friction losses. Every elevation change adds energy demand. This is basic engineering, and it is precisely why calling the system a river glosses over the most important part of the story. Nature does not send an electricity bill. Infrastructure does. Proponents often highlight the decision to place much of the system underground. This is not about secrecy or aesthetics, it is about efficiency. In an environment where surface temperatures can soar and evaporation rates are extreme, burying pipelines reduces water loss and protects the infrastructure from heat and sand. From a German engineering perspective, this is the most rational design choice in the entire project. If you are going to move water across a desert, you hide it from the desert. At the same time, going underground raises its own challenges. Inspection becomes harder, repairs take longer, leaks are less visible. In a system of this size, even a small percentage of loss translates into enormous absolute volumes. For Americans familiar with aging water infrastructure at home, this should sound familiar. Leaks are not a theoretical risk, they are a certainty over time, and managing them is part of the real cost of any long-distance water network. The way Saudi Arabia presents this corridor also reflects a political calculation. By framing it as a river, the project is tied to ideas of nation-building and permanence. Rivers shape civilizations. Pipelines serve them. The metaphor elevates the project from utility to legacy, aligning it with the broader narrative of transformation and modernization promoted under Saudi Vision 2030. It suggests a future in which water scarcity is no longer a defining feature of national identity. International coverage, however, tends to be more cautious. Reporting by outlets such as Reuters and Bloomberg consistently emphasizes infrastructure, capital expenditure, and operational complexity rather than poetic imagery. This difference in framing is not accidental. It reflects the gap between how megaprojects are sold domestically and how they are evaluated externally by investors, engineers, and policymakers. For a U.S. viewer, the most useful way to judge the project is not to ask whether it looks impressive, but whether it behaves predictably under stress. How does the system respond to power outages? How much redundancy is built in? What happens when one segment needs to be shut down for maintenance? Rivers answer these questions through geography. Pipelines answer them through design and spending. This is the heart of the artificial river story that rarely makes it into viral summaries. The project is not a single bold stroke. It is a sprawling web of engineering decisions, each one trading flexibility for control, and each one locking the country into decades of operational obligations. If it succeeds, it will quietly redefine how water moves in Saudi Arabia. If it struggles, it will do so in ways that are invisible on a map, but painfully obvious on a balance sheet. At the center of Saudi Arabia's water strategy is desalination, a technology that sounds almost magical until you reduce it to physics. You take seawater, you remove the salt, and you are left with something people can drink and crops can use. The trick is not whether it works, it does. The trick is how much energy it takes and how reliably you can supply that energy at national scale. This is where the artificial river stops being a story about water and starts being a story about power. Modern Saudi desalination relies primarily on reverse osmosis, or RO, a process that pushes seawater through membranes fine enough to block salt molecules. Compared with older thermal methods that boil water and condense the vapor, RO is significantly more energy efficient. That efficiency is the only reason projects of this size are even imaginable today. Without it, the electricity demand would be so extreme that the idea would collapse under its own weight before the first pipe was laid. Saudi Arabia has built its global leadership in desalination around this shift. According to data released by the country's own water authorities and cited in international reporting, the kingdom now produces fresh water at a scale measured in tens of millions of cubic meters per day. That makes it the largest desalination producer on Earth, ahead of countries with far larger coastlines and far more rainfall. The artificial river is not a leap into the unknown. It is an extension of an industrial capability Saudi Arabia already operates every day. But extension is where the costs compound. Reverse osmosis does not eliminate energy demand. It compresses it into a more manageable range. On average, producing 1 cubic meter of desalinated water via modern RO requires several kilowatt-hours of electricity. Multiply that by daily output in the double-digit millions of cubic meters, and you are no longer talking about marginal consumption. You are talking about a power load comparable to that of major industrial sectors. This is the part of the story that rarely survives into promotional narratives. Turning seawater into fresh water is not a one-time investment. It is a permanent energy obligation. Every liter delivered inland is tied to power plants, fuel supply, grid stability, and price volatility. If electricity is cheap and reliable, the system hums. If it is not, water security becomes vulnerable in a new way. From a German analytical standpoint, this is a textbook example of the water-energy nexus. you do not solve scarcity, you shift it. The limiting factor moves from rainfall to kilowatt hours. That trade-off can make sense in a country with vast energy resources, but it is never neutral. Institutions like the International Energy Agency have repeatedly warned that large-scale desalination binds water policy tightly to energy markets, especially in regions where cooling demand and water demand peak at the same time. Saudi planners are clearly aware of this. The country's broader infrastructure strategy emphasizes efficiency upgrades, grid expansion, and, increasingly, the integration of renewable energy into water production. Solar power, in particular, is often mentioned as a long-term complement to desalination, not because it is free, but because it aligns with peak daytime demand and reduces exposure to fuel price swings. Whether that integration can be achieved at the scale required by the artificial river remains an open question. For an American audience, the analogy is straightforward. Imagine replacing a natural watershed with a system of electrically powered pumps stretching across several states. As long as the grid is stable, water flows. When the grid is stressed, water becomes part of the crisis. Hurricanes, heat waves, and energy shortages no longer threaten comfort alone. They threaten supply itself. The reliability of the water system becomes inseparable from the reliability of the power system. This is why the artificial river should not be judged by its headline capacity alone. Producing water is only half the equation. Moving it inland, uphill, and across extreme climates magnifies every inefficiency. The engineering challenge is impressive, but it is also unforgiving. Small miscalculations at this scale do not create small problems, they create systemic ones. In that sense, desalination is neither a miracle nor a mistake. It is a tool. Saudi Arabia is choosing to use that tool more aggressively than any country before it, betting that its energy base and financial reserves can absorb the long-term costs. Whether that bet pays off will depend less on membranes and pipes than on power prices, grid resilience, and the discipline to treat water as an industrial product rather than a political symbol. If the artificial river has a weak spot, it is not engineering. It is the bill that comes after the cameras leave. Large water systems do not fail because pipes cannot be built. They struggle because operating them year after year turns into a permanent financial and energy commitment that is easy to underestimate and politically uncomfortable to discuss. This is the part of the story that Megaproject videos usually rush through, because spreadsheets do not trend well. Start with energy. Modern reverse osmosis is efficient by historical standards, but efficiency does not mean cheap when scale explodes. Producing 1 cubic meter of desalinated water typically requires several kilowatt hours of electricity. Multiply that by daily output measured in the tens of millions of cubic meters, and the artificial river becomes one of the largest continuous electricity consumers in the country. This is not peak demand that comes and goes. It is baseload, running every hour of every day. Now add transport. Moving water hundreds of kilometers inland is not passive. Pumps must overcome friction losses, elevation changes, and system pressure. Each additional kilometer adds energy cost. Each pumping station adds maintenance risk. The farther the water travels from the coast, the more expensive every liter becomes. From a German accounting perspective, this is classic diminishing returns. The first kilometers are manageable. The last ones are brutally expensive. Then there is maintenance. Pipelines of this size do not simply sit there and behave. Valves fail. Sensors drift. Corrosion never sleeps, even in systems designed to resist it. Sand, heat, and time are relentless. In a 12,000-kilometer network, even a failure rate that looks trivial on paper turns into a steady stream of repairs. That means skilled labor, spare parts, downtime, and contingency planning. These costs do not show up in launch announcements, but they dominate the lifecycle budget. Supporters often argue that Saudi Arabia can afford this because energy is cheap and capital is available. That argument is only half true. Energy is cheap when oil and gas prices are favorable and when domestic consumption does not compete with exports. Capital is available when priorities are aligned. But infrastructure locks in obligations that outlive political cycles and market conditions. What looks affordable in a year of surplus can look very different in a decade of tighter margins. For an American audience, the closest comparison is not a dam or a power plant. It is a nationwide utility system layered on top of an already stressed grid. Think about aging water pipes in US cities. The initial construction cost was paid generations ago, yet maintenance still drains municipal budgets today. Now imagine a system orders of magnitude larger, operating in harsher conditions, and tied directly to energy prices. That is the financial reality Saudi Arabia is signing up for. This is also where the artificial river intersects with broader economic reform. Under Vision 2030, the kingdom is trying to reduce wasteful subsidies and price resources more realistically. Water pricing has already been adjusted upward in stages. A desalination corridor makes that reform unavoidable. When water is produced through energy-intensive industrial processes, underpricing it becomes fiscally dangerous. Either consumers pay more, or the state absorbs the difference indefinitely. There is an irony here that deserves attention. The project is often framed as a way to free Saudi Arabia from natural constraints. In practice, it ties water security to energy markets and fiscal discipline. The desert is no longer the enemy, volatility is. If electricity costs rise, water costs rise. If infrastructure investment slows, reliability suffers. Scarcity does not disappear. It changes its address. This does not mean the project is doomed. It means its success depends on something far less dramatic than engineering prowess. It depends on boring, sustained competence in pricing, maintenance, and long-term planning. The artificial river can deliver water. Whether it can deliver it at a cost that remains politically and economically acceptable over decades is the question that actually matters. Every large water project creates waste. Desalination simply makes that waste harder to ignore. For every cubic meter of fresh water produced, more than 1 cubic meter of highly concentrated salt water, known as brine, is left behind. This is not a side detail. It is an unavoidable byproduct, and at the scale Saudi Arabia is operating, it becomes an environmental issue with regional consequences, rather than a local nuisance. According to assessments by the United Nations Environment Programme, global desalination already produces billions of cubic meters of brine every year, much of it discharged back into coastal waters. Saudi Arabia, as the world's largest desalination producer, is also one of the largest brine producers. The artificial river does not change that equation. It amplifies it. The Red Sea, one of the primary sources for Saudi desalination plants, is not an empty sink. It is a narrow, semi-enclosed body of water with unique coral ecosystems and limited water exchange compared to open oceans. Increased brine discharge raises local salinity and temperature, stressing marine life that has already adapted to extreme conditions. Even small changes can have outsized effects when repeated day after day, year after year, at industrial scale. This is where the megaproject narrative starts to crack. Videos tend to frame desalination as a clean conversion process, turning unusable seawater into life-giving fresh water. In reality, it is more accurate to describe it as a trade. Fresh water is produced, but environmental pressure is shifted offshore. The desert gets greener. The sea pays part of the price. Saudi planners are not unaware of this. Environmental impact assessments, diffusion techniques, and mixing strategies are often cited as mitigation measures. Brine is diluted, dispersed, and released in ways designed to minimize immediate harm. But mitigation is not elimination. The long-term cumulative impact of constant high-volume discharge remains difficult to model with precision, especially in sensitive marine environments. From a German analytical perspective, this is a familiar pattern. Infrastructure projects often externalize costs that do not appear on balance sheets. The benefits are counted in cubic meters delivered and cities supplied. The costs accumulate quietly in ecosystems, showing up later as degraded fisheries, stressed coral reefs, or increased monitoring and remediation expenses. These costs are real, even if they are harder to quantify. For an American audience, the analogy is again practical. Think of industrial facilities that meet every regulatory requirement, yet still alter surrounding ecosystems over decades. Compliance does not equal zero impact. It simply defines what level of damage is considered acceptable. Desalination operates within that same logic. The artificial river also raises questions about transparency. Brine management is rarely discussed in public-facing narratives because it complicates the story. Water security sounds clean. Marine impact sounds technical and inconvenient. Yet, if the project is to be judged honestly, these impacts cannot be treated as footnotes. They are structural features of the system. There is a deeper irony here. Saudi Arabia is attempting to solve one environmental constraint by leaning heavily on a technology that creates another. That may be a rational trade-off in a water-starved country, but it is still a trade-off. Sustainability, in this context, does not mean harm-free. It means choosing which harms are tolerated and which are not. This is why international organizations continue to push for greater disclosure and long-term monitoring in desalination-heavy regions. The artificial river will not be judged solely by how much water it delivers inland, but by how responsibly it manages what is left behind on the coast. If brine becomes the project's blind spot, it risks turning a water security solution into an environmental liability that future governments will have to confront. When you strip away the metaphor and the promotional language, Saudi Arabia's so-called artificial river is neither a miracle nor a fantasy. It is a deliberate, high-stakes infrastructure choice made by a country that has already learned, the hard way, what happens when water policy ignores physical limits. This project exists because the old model failed. Fossil groundwater was drained. Domestic wheat production collapsed under its own weight. Subsidies masked scarcity until scarcity became unavoidable. The artificial river is the response to that history, not a denial of it. From a strictly technical standpoint, the logic is coherent. Saudi Arabia has abundant coastline, enormous experience in desalination, and an energy system capable of supporting power-hungry industrial processes. Building a national water corridor is the next step if the goal is to stabilize urban growth, industry, and selected forms of agriculture without continuing to mine non-renewable aquifers. In that sense, the project is less radical than it sounds. It extends existing systems rather than inventing new ones. The real uncertainty lies elsewhere. The first unanswered question is money. Not just construction cost, but life cycle cost. Pipelines, pumps, membranes, and control systems do not age gracefully in extreme heat and sand. They demand constant investment. Over decades, operating expenses matter far more than the initial price tag. Any serious evaluation of the artificial river has to ask whether future governments will maintain the discipline required to fund maintenance when the political spotlight moves on. The second question is energy. Desalination ties water security directly to power availability and pricing. As long as electricity remains cheap and reliable, the system works. When energy markets tighten, water becomes exposed. This coupling is not theoretical. It is built into the physics of reverse osmosis and long-distance pumping. The artificial river does not escape scarcity. It relocates it from rainfall to kilowatt hours. The third question is environmental accountability. Brine discharge, marine ecosystem stress, and cumulative coastal impacts are not side effects. They are intrinsic to desalination at scale. Managing them responsibly requires transparency, monitoring, and a willingness to confront uncomfortable trade-offs. If these costs are ignored or minimized in public narratives, they will resurface later as political and ecological problems. For an American audience, the takeaway should be familiar. This is what happens when a society decides to engineer its way around geography. It can work, but only with relentless attention to cost, risk, and long-term consequences. Big infrastructure does not forgive optimism. It rewards realism. The artificial river may well become a cornerstone of Saudi Arabia's water security for decades to come. Or it may become a cautionary case study in how ambition collides with operational reality. The difference will not be decided by how bold the project sounds today, but by how honestly it is managed tomorrow. Thanks for watching and reading, and I would really like to know what you think about this project, and whether you see it as a smart solution or a risky gamble. So leave your thoughts in the comments below.